Hello, today we're going to be doing a video on explaining on exactly what is a limit and what does it do. You can think of a limit as the value of x as it approaches a given point can be thought of as constraints. This is what a limit is. It's constraining at a given point on that function to see how does that function act exactly in that area of the function. In order to do this, we must use limit laws, limit rules. Some pretty common ones, if you have a function, two functions that are being multiplied together, and you have the limit as x approaches a given point, you can think of this as, you can actually separate the two functions, the limit as x approaches a, f of x, times the limit as x approaches a, gx. So when they're multiplied, you can actually separate them like that. When you have the limit as x approaches a with a given function to a power, you can actually take the brackets, expand them over the whole thing, and just keep your power. So you're not really having any major changes. The only thing that you're doing is you're expanding the brackets. Another one is if you have the limit as x approaches a to the nth root, f of x, just like up here, you can take the root and expand it over the whole thing, keeping your nth root. Okay, and then we can come over here as the limit as x approaches a, f of x divided by g of x. Again, just like all the other basic rules, you can think of them as being separated, having your limit x of a on top and bottom, both functions still exactly the same. Basically what we're trying to get at is if f of x equals g of x except when x equals a, then the limit of x approaches a, f of x, is equal to its counterpart, limit as x approaches a, g of x. We can use these limit laws with given functions as the limit approaches a given point to solve an equation. So now let me show you how to do that. Now we're going to erase this. Say we have the limit of 3x squared as x approaches 2. Now we can use the limit laws that I was talking about, a basic one, and do this. The limit as x approaches 2, 3 times the limit as x approaches 2, x squared. Now, we see here this does not have a 2, or an x, I apologize. So this does not have any great meaning. This, however, does have an x. So we can plug in that 2 to that x squared. So now what we're actually going to have is just 3 times 2 squared. Pretty basic and pretty simple, right? So 2 squared is 4, 3 times 4 is just 12. And that's what your x is equal to. That's it. Now we can do another one. Do a rational function this time. As the limit of x approaches -1 to the given function x minus 5 divided by 2x, we can think of this again, as you know in one of the other ones. Basically, you don't have to write, the limit as blah, 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 blah. As long as you know to plug in that -1 to where the x is, you can just think of it like this. -1 minus 5 to the -1. Okay. -6, -2, 3. It's just that simple. Okay. Now, I've showed you how to do the math of figuring out what the limit is, but you might not actually understand what it does specifically, so I'm going to go ahead and draw you a graph. I'm going to do, let's just say x. Okay. On that graph, when you're doing the limit, so you have 1 there, 2 there, 3 there. So I want to find out where to, how does the function acting? So we set up our constraints, which is known as our limits, and in here in the graph we are figuring out by using our math of the function what is it acting like as x approaches 2. And there you go, that's exactly what we were doing.